Hi students, let's look at this question here which was taken from the year 2018, the A-level H2 math paper. Paper 1, question 7. Let's see how we can do this professionally. This question is on applications of differentiation. So a curve C has an equation of this. So show dy dx is this expression here. So let's look at how we can do this. First thing is we're going to just cross multiply, right? So in this case, I'm going to just cross multiply. Then after which we're just going to try and find dy dx by using implicit differentiation. So 2x squared plus 4y squared is equals to 1 multiplied by x squared plus xy squared. So this case will be 2x squared plus 8y squared is equals to x squared plus xy squared. So differentiate with respect to x, what we get is 4x plus 16y dy dx implicit differentiation. Then this over here is 2x, and this will use product rule. Just be careful of this. So it's 2y dy dx plus y squared multiplied by 1. So this case here, this is my u, this is my v. So u dv dx plus v du dx. Okay, so this is how we do this. So once we're done, what we're going to do is just move dy dx. Okay, so I'm going to just replace this 2xy dy dx. So we need to find dy dx. So meaning to say, we need to move dy dx to the other side. Oh, this is plus. Okay, great. So sorry, typo. Wrote wrong, copied wrongly. So once it's done, what we can do is just move this over to the other side. So 4x minus 2x minus y squared. Then after which you have 2xy dy dx plus 16y dy dx. All right. Then from here, what is 2x minus y squared equals to dy dx 2xy plus 16y. Great. Now once this is done, what we could do next is essentially just divide. So dy dx is equals to 2x minus y squared over 2xy plus 16y. Okay, so that's how you do the first part. Let's look at the second part. Second part is essentially the point P and Q on C each have x coordinate of 1. The tangent of C at P and Q meet at point N. Find the exact coordinates of N. Okay, great. Now we do not know how this curve looks like, but what we know is there are 2 points which corresponds to a coordinate, x coordinate of 1. So this case here, if I would just put a 1 here, because there are 2 points, I'm not sure which is P and Q, but either is fine, I believe. We just need to find the y coordinate, then after which find the equation of tangent and just use the equations of tangents to simultaneous equation. We should be able to get the answer there. All right. So to illustrate this, I think I'm just going to explain by using a Desmos curve. Now, obviously, we don't really know how to sketch this curve here, the equation C. So this is equation C. As you can see on Desmos, when x equals to 1, we have got intersect at these 2 points here. So what they're trying to say is that the equation of tangent of this point here and this point intersect at a point N. Okay, so that's why we have 2 points. So we're gonna just find out what's y first. So when x is equals to 1, okay, and we need to find out what's y. So sub x equals to 1 into C. What we have is 1 square minus 4y square equals to 1 square plus 1 multiplied by y square equals to half. So this is 2 1 minus 4y square equals to 1 1 plus y square. All right. So 2 minus 8y square equals to 1 plus y square. That'll be 1 equals to 9y square. So y square is equals to 1 over 9. Y would just be plus minus square root 9, which is actually 1/3 or negative 1/3. Okay, so we have 2 coordinates here. So this is either 1/3 or minus 1/3. Okay, so it happens to be symmetrical about the x-axis. So that's that. Once this is done, we need to find the tangent at this point. So this is 1 and a third. Then this is 1 and negative a third. So what we're going to do is actually just when for x equals to, for y equals to 1/3 and x equals to 1, the m tangent will be dy dx, replacing it x and y into this equation. All right, that's all. So what I'm gonna just do that. So from here, what we get is 2 multiplied by 1 minus of 1/3 square over 2 multiplied by 1/3 plus 16 and a third. Okay, put in calculator. So key in calculator here, what we get is 17 over 54. So the equation of tangent here, I'm just going to use y minus y1 equals to mx minus x1. Okay, just a simple equation of line. Then from here, what we're going to do is just y minus 1/3 equals to 17, 54, x minus 1. All right, so just manipulate this. This is the equation of tangent here. 17 over 54 plus a third. So I got this equation here. Y equals to 17 over 54x plus 1 over 54. This is the first equation of tangent. So maybe I just put this aside. All right, so in other words, this tangent equation here will be something like that. All right, 1 over 54, so it's like that. So y okay, great. So now we're going to find the other equation of tangent. So the other equation of tangent will be when for y equals to negative 1/3. You do the same thing. I think the m tangent here, just replace it in. After which is 2 I believe it's negative 17 over 54. So then after which you use the same formula, equation of tangent. Anyway, y minus negative 1/3 equals to negative 17 over 54 x minus 1. So here will be y equals to negative 17 over 54 x plus 17 over 54 minus 1/3. What we'll get is y equals to negative 17 over 54 x minus 1 over 54. All right. In other words, is this line here. It would be symmetrical about the line that we found just now. I believe the y coordinate will be x here. Okay. So anyway, we're just gonna solve the because they want both of them would intersect at n, right? Tangent meet at point n. Find the exact coordinates of n. Okay, great. So what we do is we just use simultaneous equation from GC, solving 1 and 2. I think you'll be able to get the exact value there. Maybe I rearrange this into simultaneous first. So y minus 17 over 54x equals to 1 over 54. This is 1. After which this is y plus 17 over 54. X equals to negative 54. This is number 2. From GC, we will get x is equal to 0. Interesting. No, y equals to 0. And x equals to negative 1 over 17. Hence, coordinates of n are negative 1 over 17, 0. Alright. So that's how you do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.